Hi, I'm Hitoshi Murayama. I work both at the University of California, Berkeley, as well as University of Tokyo. And I'm giving 4 lectures about the recent status of our understanding about the universe. So the title of my lectures is From the Big Bang to Dark Energy. And the Big Bang, as everybody know, is the beginning of the universe. So in most of my lectures, I will be talking about how we understand how the universe began, starting from where things are today, and gradually go back in time and try to reach as much as possible to the very beginning of the universe. But towards the very end of my lectures, I'm going to talk about the future of the universe that has to do with this other part of the title called dark energy. So in our understanding of the universe has made a huge progress in the last 15 years or so. And what we used to think we knew about the universe is now totally wrong and outdated. It's sort of undergoing a big revolution right now. So what I'd like to communicate to you in these lectures is what we have learned in the last 20, 15 years and what we think we know about the beginning of the universe as well as the future of the universe. And we try to put that together in a bigger context. So I organized these contents in 4 lectures, as I said already. And it will be extremely helpful if you know some calculus. But I also organize the content in such a way that if you want to skip some of the equations, you can do so. And still, you can probably get some conceptual understanding of what's going on there. But if you do know calculus, then you can follow some of the equations and get a deeper understanding that way. And the homeworks will also be organized in a way that you have some conceptual problems, which you can understand without the need of calculus, and some other more advanced problems where you really need to do some math and algebra to work things out. So hopefully this kind of combination would reach you to a much wider audience that way. So many of you who may not have that kind of background, you can still get something out of my lectures, hopefully. And if you do, you can get a lot more that way. Okay, so that's the way I would like to get started. So as I said, from the Big Bang to dark energy. And the kind of questions we would like to ask in these lectures are really sort of questions you might have had when you were a little child. So if you go to, let's say, vacation and camping, you watch up the sky and the starry sky in the evenings. And of course, one of the sense we always get is kind of awe. We always feel that the universe is so beautiful, stars are so beautiful. We'd like to at least understand what's going on there. And you tend to get into really philosophical thoughts just by looking at the stars. And this is kind of questions you might have asked when you're little. How did the universe begin? So this is such a big universe out there. But we hear that was actually the beginning. That's the Big Bang. So what exactly was the Big Bang? How did the universe begin? And the next question might be, what is its fate? So we live in this universe, and of course, for natural reasons, we would like to understand where we're heading to. And that is about the fate of the universe. And that has to do with this last part of my lectures called dark energy. What is it made of? And for us to understand how the universe works, of course, we need to understand what the universe is made of. And as we'll tell you as we go along, we used to think that the entire universe was made of kind of atoms we are made of as well. But that actually didn't turn out to be the right understanding. And you will see that atoms make up only less than 5% of the entire universe. And the rest is actually unknown. So we will talk about these things as well. And what is fundamental laws? And of course, for us to understand how the universe works, we need to understand its basic laws. So there are laws of physics that tell you how things fall, how things move, and so on and so forth. And there are also laws that would govern the evolution of the universe as well. So we will talk about some of these things. Finally, of course, we are very curious about where do we come from? And in order to understand where we come from, of course, there are part of the questions may be biological or evolution. But the part of the questions also has to do with what are we made of and where did our ingredients come from? Where did the chemical elements come from? And why do we have matter in the universe? I would also mention that antimatter, which could have been in the universe, is actually not there. So that's the kind of question we would like to understand as well. And all of these questions, as you see on this list, used to be in the realm of, say, theology or philosophy. But now we can address some of these really big questions, fundamental questions in the realm of science. And that's the kind of progress we are making these days. And that's extremely exciting. So I'd like to tell you what these excitements are as we go along. So as I told you already, I organize my lectures in 4 lectures. So the first one today is from daily life to the Big Bang. And when you think about the universe, you might have this impression that, well, it's far out there, has nothing to do with me. But that's not true at all. What we experience in daily life actually has a lot to do with what's going on in the universe. And that eventually leads all the way back to the Big Bang. So that's the first lecture I'm going to present today. In the second lecture, we will talk about the birth of elements and something you have heard about recently, the Higgs boson. So if you think about where we come from, we're made of chemical elements. And unless there are chemical elements out there in our universe, we couldn't have possibly be born. So where do they come from? That actually turns out to be a real scientific question we can ask today. And I can tell you about our recent understanding about this. And it does have to do with this newly discovered Higgs boson that was discovered on July 4th, 2012. And without this Higgs boson, we could not exist. So that's the connection I'd like to make in my second lecture. In the third lecture, we get into a more mysterious side of the universe. The first one is called dark matter. And this dark matter is actually a bulk of matter in our universe, but we still don't know what it is. At the same time, though, we know that dark matter played a very important role in forming the universe as we see today, and without it, again, we could not have existed in this universe. So we'd like to talk about what it may be and what we're looking for so that we may gain some understanding on the nature of dark matter as we continue our research program. And the second half of the lecture will be antimatter. And antimatter may sound like something that might show up in the science fiction movies, but they do exist. We can even make them. So they actually must have been born at the very beginning of the universe in the Big Bang. But fortunately, antimatter doesn't seem to exist today. And that's actually very important as well. So where did it go? So that's another very fundamental question about where we came from, how we come to exist. And so absence of antimatter is a very important question, it turns out. In the final lecture, the lecture number 4, we talk about inflation and dark energy. So if we really want to go back to the very, very beginning of the universe, we think, it's still hypothesis, but there's a very good evidence for it, we think there was a period called cosmic inflation that made a universe that was born at a much, much smaller size than an atom to a macroscopic size we see today. That's a tremendous expansion of the universe, and that idea has been borne out with the latest data, so we will talk about that. And that was what happened at the very beginning of the universe. But it so happens that the universe seems to have started yet another stage of inflation very recently. And that has to do with this last subject called dark energy. And depending on the nature of dark energy, the universe may have an end or may continue expanding forever. We don't know which one is the right future yet, but dark energy is definitely the key to that question. So we'd like to talk about this very beginning of the universe as well as what might be waiting for us in the future that has to do with the nature of dark energy. So that will be my fourth lecture. So that's the way I organize my lectures for this course.